In these set of videos, we are trying to understand how to write equation representing sinusoidal functions from the given information. Now in question number 1, we wrote the equation from the data. Now here we are given some points. So question number 2 is, write equation of a sinusoidal function with maximums at 1, 6 and 5, 6 with minimum value of -2. So let me just sketch one sinusoidal function here, and then we will work out the equation for the same, right? So just draw a sine function, right? Don't bother about x's and all those things, right? Don't bother about coordinates, that's what I'm trying to say. And let's put the points which are given to us. Maximum 1, 6. So this is first maximum for us given at 1, 6. And then the second one is given to us at 5, 6, right? The minimum is -2. So this value, we don't know the x value, but we know the y value is -2, right? X, of course, will be right in the center, so we can always work it out, correct? So let me, for the time being, write -2 here. So that is the kind of information given to us. Now from this information, we can find the time period, right? So the time period for us is difference between two consecutive maximums. So it is 5 minus 1. 5 minus 1 is 4, so we get time period of 4. Now from time period, we can find the value of k, which is 360 degrees divided by 4, correct? That means 90 degrees. I hope you understand what we are trying to say when we say k here. So what we're trying to say is that we are going to write down our equation of the function as f of x equals to a times f of k times x minus t plus c, right? Now here k is actually equals to 360 degrees divided by the time period, right? So those of you who are doing in radians, they can write this as 2 pi divided by time period, right? Now in this case, we found k is 90, right? So we'll do all these calculations here. So that is what we have. Now what is c equals to? C, as you know, is equals to average of maximum and minimum values, right? So it is maximum minus minimum divided by 2. So let's find out c now. Maximum value is 6 for us, and the minimum value is -2 divided by 2, right? So 6 minus 2 is 4. 4 divided by 2 is 2. So we get c as 2, correct? So let's just draw add to a line here. So that means the y value of 2, right? So we have y equals to 2 as our axis. Now from here we can find the amplitude, right? So the amplitude is basically maximum minus c, right? Maximum minus c. Maximum is 6 for us. 6 minus 2 gives us 4. So we know amplitude also. How about d? D is the phase shift, and if we consider this to be a cosine function, the first maximum gives us the value of d, the x value, so which is 1 for us, this one itself, right? That gives us all the information, right? So we get a as equal to 6 minus 2, that is 4, right? We get c, which let me write again here as 2, and we know d is equals to 1, the first maximum position, right? So this is indeed the value of d, right? That is the value. So that gives us the equation, and we can write f of x, the function, as equal to 4 times, we are using cosine function now, cosine, and k value is 90, right? 360 divided by 4, so that is 90, x minus 1, right? Plus c, and c is 2 for us, plus 2. So that is how we can get equation from the given data, right? So as an exercise, what I like you to do is write down the sinusoidal function for the same. And let's see. Remember that sine wave and cosine waves are shifted by quarter of a cycle, or in general 90 degrees for the basic parent function, right? So that is how they are related. So you can find the sine function from this equation, right? Or the information. I hope that shouldn't be so difficult for you. Thank you. Let's move on and see some more examples to understand how to write equation from the given information for a periodic sinusoidal function. Thank you.